Okay, hi guys. So in today's video, we're going to be looking at waves and wave properties. And for this, you've got to be able to describe the difference between transverse and longitudinal waves, describe evidence that waves transfer energy and not matter, describe waves in terms of amplitude, wavelength, frequency, and period, and then also be able to explain how wave speed, frequency, and wavelength are linked. Sounds easy, right? So let's get into it. So there are two types of wave. They are transverse and longitudinal. And all waves, no matter whether they're transverse or longitudinal waves, they transfer energy from one place to another. So an example of this is if I were to drop a stone into a pond, and what you would get is, and we've all done it, we've all thrown stones in ponds or bodies of water, we see ripples travel outwards carrying that energy. But what's important to understand is that the water does not travel outwards itself. Otherwise, what would happen is you'd end up with a massive hole in the middle of the pond. Okay, hopefully that makes sense. So it's the energy traveling, not the actual matter that makes up the water. Now it's the particles that make up the wave. They begin to oscillate, and oscillate just means vibrate, and they oscillate about a fixed point. And in doing so, they pass the energy on to the next particles, which then also oscillate, and then they pass on that energy to the next particles, and so on, and so on, and so on. Okay, so just remember it's the energy that moves along, but the matter remains. Okay, so it's the energy that travels, not the matter. Okay, so in transverse waves, examples of that like light or water on the waves on the surface of water, the oscillations are perpendicular or at right angles to the direction of energy transfer. Now we could demonstrate that, although I don't have it on me at the moment, we could demonstrate that by moving a rope or a slinky spring up and down vertically, and what you would see is then the wave moves horizontally. So the next wave we'll look at is the longitudinal wave. And an example of a longitudinal wave, a good one to remember, and one that always comes up to remember, is a sound wave. So a sound wave is a longitudinal wave. Now the oscillations are in parallel to the direction of energy transfer. Now again, this could be demonstrated on a slinky spring, and if I was to flick the slinky spring, it would travel, or the energy that I've just used to make my slinky move would go back and forward horizontally. So the wave is also moving horizontally or in parallel. Now, let's talk about some properties of waves. Now, all waves, whether they're longitudinal or transverse, have frequency. So frequency means the number of waves passing a fixed point per second, and they're measured in hertz or Hz. The next one is amplitude, and you'll see that on my diagram just behind me. So the amplitude is the maximum displacement that any particle achieves from its undisturbed position in meters. The next one is wavelength, and you can see there on my diagram behind me, we've got wavelength. So the wavelength is the distance from one point on a wave to the equivalent point on the next wave, and again, in meters. And the last one we need to talk about is period. So the period is the time taken for one complete oscillation in seconds. Now, when observing waves, like waves on water, it's important to remember that the amplitude is seen as the wave height. And then the next point is the period is the time taken for one complete wave to pass a fixed point. And that can be worked out using this equation behind me. So that is period equals 1 divided by the frequency, or T equals 1 divided by F. Okay, so the next thing we need to talk about is wave speed. And the speed of a wave is the speed at which the energy is transferred or the wave moves. Now, it's a measure of how far the wave moves in 1 second and can be found with the wave equation. Wave speed equals frequency times wavelength, or V equals F times lambda, which is that funny upside down Y looking H ring. Now, ripples on the surface of water are slow enough that their speed can be measured by direct observation and timing with a stopwatch. So there is a required practical that comes with that, and I will do a separate video on that as well. Hopefully you found that interesting. Hopefully it's helped with your revision. Like, follow, share for more revision GCSE hints and tips at combined science and separate science. See you later.